In this video, we will take our knowledge of linear equations and apply it to word problems. So let's get started. The overall price of owning a cell phone can be represented by C equals 450 plus 60M, where C represents the total cost and M represents the number of months. Now, what's really important here is that when you see a word problem, you don't just jump to the equation and just start with A and B. Really understand what the variables represent, because that will help you in knowing where to plug your numbers in. So C is our cost and M is our months. So let's see, for A, how much will your phone cost after 3 months? All you have to ask yourself is, do I put the 3 months in for C or for M? 3 is the number of months, so we are going to replace M with 3 in our equation. So I'm rewriting everything, except instead of the M, I'm going to put the 3 months. And now we can just simplify this. So thinking about bed mass, we do 60 times 3 first, which is 180. And then we can add up the 450 and the 180 to get 630. Now this is going to represent the total cost for 3 months. And because this is a word problem, we are going to write our therefore statement. Therefore, 3 months will cost $630. Okay, let's see B. You decide to get a new phone after spending a total of $2,010 for the one you currently have. How old is your phone? So they're pretty much asking us, how many months have you had your phone for? And this 2010 represents the cost. So in this scenario, we're going to replace C with this number. So 2010 is equal to 450 plus 60M. Notice I didn't carry over the 3 months from before. These are completely separate questions. And now when I look at this scenario, my goal is to figure out M, so I have to isolate it, which just means we're going to solve our linear equation. And this is just a 2-step equation. So let's bring the 450 to the other side. Its sign changes. So now 2010 subtract 450 is 1,560. And to isolate for M, we have to get rid of 60. The opposite of multiplication is division. And we do that to both sides to get a total of 26 for M. And now maybe by now you've forgotten what the question was, but it's how old is your phone? So therefore, the phone is 26 months old. And that's it. So there are 2 types of questions here, either plugging in for the variable and then just going to your calculator and simplifying, no isolating required, or plugging into the other variable that actually forces you to solve a linear equation. So let's try the next one. The new ice cream shop in town has the following deal on. Buy a double scoop of vanilla or chocolate ice cream for $4 and then pay 50 cents per topping. This relationship can be modeled by the equation C equals 4 plus 0.5n, where C represents the total cost and n represents the number of toppings. So these variables, we know what they mean now. Now in this scenario, I did give you the actual deal, so we could have come up with the equation on our own, but we're saving that for another unit. So for now, you will be given the equation and we just have to figure out what to plug in where. So if you want 3 toppings, how much will your sundae cost? So toppings is represented by n. I want 3. So I'm going to go to my equation, C equals 4 plus 0.5. And then instead of n, I'm going to put 3. And now I clean up. 0.5 times 3 is 1.5, because multiplication goes first. And now we add our numbers to get 5.5. So therefore, 3 toppings will cost $5.50. What about if we go the other way around? You have $8 in your pocket. How many toppings can you get? So this $8 is going to represent the total cost of this sundae, or the potential total cost. So let's set C equal to 8, and then we can write the rest of the equation. And now the basic two-step equation. Bring the 4 over so that we have 8 minus 4 equals 0.5, and so that's 4. And now, once again, we need to get rid of that coefficient, so we'll divide both sides by 0.5, and we get 8 for n. So that means 8 toppings. Therefore, you can get 8 toppings on your sundae. So there we are. Let's try another one. And in this next one, the equation will be slightly different, but still same idea. The ballet charges $160 for adult tickets and $80 for child tickets. On Saturday night, they made $26,000. This relationship can be modeled by the equation 160A. So there's the 160 from the adult ticket price plus 80C equals the total money coming in, which is $26,000, where A represents the number of adult tickets sold and C represents the number of child tickets sold. So if they sold 120 adult tickets on Saturday, how many child tickets were sold? So that means we're going to replace A with 120. So just rewriting my equation, but I did just hit A, so I'm going to replace it with 120. And then I'll write the rest of it out. And now this is going to be a scenario where I have to solve the equation, but before I move anything over, I am just going to do a little bit of multiplication here. 160 times 120 is 19,200. And now that I've cleaned that up, this looks more like a typical two-step equation. So we can bring that 19,200 over, remembering to switch the sign, or something won't really make sense later on. And when we do that subtraction, we get $6,800 left. So that means that we have $680 or $6,800 from the child tickets. Each ticket was $80, so we'll divide both sides by 80. If you get a decimal number, that will not make sense, but we did get a nice whole number of 85. So therefore, 85 child tickets were sold. And now the next one. Now, again, remember, these questions are not related to each other, so I don't care about the 120 adult tickets. That's over. Instead, if they sold 125 child tickets, so now we're replacing C with 125, how many adult tickets did they sell? So now it's a blank slate. I don't know what A is, but I know C is 125. So why don't you pause the video here and try to isolate for A on your own, write your therefore statement, and then come back to check your work. So hopefully for 80 times 125, you got 10,000. This 10,000 is going to move to the other side and become subtraction, so that we do get 16,000. And then we can divide both sides by 160 to get 100 for the adults. So therefore, 100 adult tickets were sold. So we're just really expanding our linear equation skills, just combining it with some application. And in these applications, we are given the equations. So let's try this last one. Jamie has $800 in a savings account that pays 2% simple interest per year. The equation A equals 800, that's the initial amount, plus 0.02, there's the percentage, times 800 times t represents the total amount A in her account after t years. How long or how many years will it take Jamie to have $864 in her account, assuming she doesn't add any money or take any money out of her account? So the value that we got here, that represents A. So let's go to our equation and replace A with 864. Now, one thing that's looking a little weird right now is having these brackets here. So I'm just going to go ahead and simplify that multiplication because it has to get done eventually. And that just becomes 16t. Now we're back to basics. Let's kick that 800 to the other side. It becomes subtraction. So that's 64. And like most of our final steps, divide out that coefficient and we get 4 for t. So here, if you forgot what that represented, it does represent the number of years. So therefore, it will take Jamie 4 years to have $864 in her account. And that's it for application. Read the question carefully, know what your variables represent, so when you are asked the question, you know where your number should go. That way you know if you're just simply going to your calculator to simplify or actually isolating for a variable to solve the linear equation.